We are going to graph log functions. And first we need to recall inverses. So we have functions over here. F of x equals 2 to the x, f of x equals 5 to the x, f of x equals 10 to the x. All of these are exponential functions. Exponential functions. Now, the inverse of an exponential function is going to be a logarithmic function. So the inverse of f of x equals 2 to the x is f inverse of x is equal to log base 2 of x. And the inverse of 5x equals 5 to the x is log base 5 of x. The inverse of f of x equals 10 to the x is log base 10 of x, and we don't show the base 10 because it's the most common logarithm. These are logarithmic functions. Exponential functions and logarithmic functions have their inputs and outputs reversed. Now, if the function starts off as a log function, it still has an inverse function that's exponential. So the inverse of log base 3 of x is going to be 3 raised to the x power. The inverse of log base 7 of x is 7 raised to the x power. And the inverse of the natural log of x is going to be e to the x power. And all of these functions are exponential functions. Exponential functions. So we're going to start with graphing f of x equals log base 2 of x. We're going to start with the inverse, which is y equals, or f inverse of x is equal to 2 to the x. We're going to say y equals 2 to the x because we're going to graph that inverse. Now we know the ordered pairs on that inverse would be 0, 1, 1, 2, 2, 4, and 3, 8. So 0, 1, 1, 2, 2, 4, and 3, 8. We are going to take each one of those ordered pairs and we are going to interchange the x's and y's. So we'll have 1, 0, 2, 1, 4, 2, and 8, 3. Now, an exponential function is going to hug the horizontal axis, and a log function is going to hug the vertical axis. And that vertical axis is going to act as the vertical asymptote. So it has a vertical asymptote of x equals 0. It has a domain of 0 to infinity and a range of negative infinity to positive infinity. It has no y-intercept, but it does have an x-intercept of 1, 0. Okay, let's try another. Here we have f of x equals log base 3 of x. So I'm going to start with the inverse of y equals 3 to the x. This will be the inverse. Y equals 3 to the x has ordered pairs of 1, 0. So sorry. I think it's 0, 1. I'm doing the log function right now. 0, 1. And then it would have 1, 3, and 2, 9. So those are the inverse. So f of x equals log base 3 of x would have ordered pairs of 1, 0, 3, 1, and 9, 2. So 1, 0, 3, 1, and 9, 2. And again, we know that this is going to come around here and hug that vertical asymptote of x equals 0. It makes sense because the domain has to be x is greater than 0. So our domain would be 0 to infinity. Our range is negative infinity to positive infinity. We have an x-intercept of 1, 0, and we have a vertical asymptote of x equals 0. Okay, you try graph f of x equals log base 5 of x. Press pause, and when you're ready to reveal the answer, come on back. Okay, welcome back. We have a domain of 0 to infinity, a range of negative infinity to positive infinity, an x-intercept of 1, 0, and a vertical asymptote at x equals 0. So our graph has a highlighted vertical asymptote, and it has points at 1, 0, 5, 1, and that's all we're able to get. And then it hugs that vertical asymptote. It does not cross, it only hugs it, and it gets closer and closer and closer without touching it. Okay, we have f of x equals log base 2 of x minus 1. Now we're going to be taking log base 2 of x, and we are going to be shifting it right 1 unit. Right 1 unit. So we know that our vertical asymptote, which is normally at x equals 0, will go right 1 unit. So it is at x equals 1. X equals 1. We know that our domain is x minus 1 is greater than 0. So x is going to be greater than 1. That will mean we've got 1 to infinity for our domain. The range will always be negative infinity to positive infinity. The vertical asymptote is at x equals 1. And now we need to plot some more points here and see what we have. Actually, there is one more thing we can do. We can take x minus 1, set it equal to 0, x equals 1, that's another way to get your vertical asymptote. So just keep that in mind, that's another way to get that vertical asymptote. Okay, so I'm going to look at my points for y equals 2 to the y equals, I've gotten better at this, log base 2 of x, and I hope you have too. Instead of 0, 1, we have 1, 0. 0, 1 is 2 to the x. 1, 0 is log base 2 of x. And then we're going to take that point and we're going to go right 1. So we'll plot that right there. Then we have on the exponential 2 to the x, when we put a 1 in, we get a 2 out. Log base 2 of x would be reversing that. Instead of 1, 2, we'd have 2, 1, and then write 1 unit. So let me show you what I'm doing. Here's 2 to the x. 0, 1, 1, 2, 2, 4, 3, 8. I'm reversing them for log base 2 of x. 1, 0, 2, 1, 4, 2, 8, 3. And then when we go right 1, which is log base 2 of x minus 1, When I go right 1, I get 2, 0, 3, 1, 5, 2, and 9, 3. Going right 1 impacts the x value. So when you go right, you're going to add 1, add 1, add 1, add 1, add 1. So that's how I'm getting those points. So if it helps you to do it that way, 1, 2, 3, 4, 5, 2, and then 9, 3. You can do it that way, or you can take all the original points and just translate them as we normally do. So we've got our x-intercept. No, we don't. Our x-intercept was the only thing that was missing. Our x-intercept is 2, 0. So we've got our domain, our range, our vertical asymptote, our x-intercept, and our graph. There's our graph. Okay, you try this next one, and I'm going to give you a hint. On this next one, it looks very similar to the one before it, except on this one, there are no parentheses. So I normally like to put parentheses, and the only thing I can put parentheses around right now is the x. If it intended for the -1 to be part of the argument, it would have used parentheses like the previous problem. So f of x equals log base 2 of x minus 1. Think about where this -1 is. It's not on the inside of the function. It's going to be on the outside. So think about what that does to your graph. Press pause, and then when you're ready to check your answers, come on back. Okay, welcome back. We have a vertical asymptote at x equals 0. And I've got points here. Normally, I would have had 1, 0, 2, 1, 4, 2, and 8, 3. And down 1 would be 1, -1, 2, 0, 4, 1, and 8, 2. So my graph looks like that. I have a domain from 0 to infinity, a range from -infinity to +infinity, an x-intercept at 2, 0, and a vertical asymptote still at x equals 0. Okay, if you'd like to give this one a try, you can give this one a try. Otherwise, stick around and I'm going to show you the ordered pairs. Log base 2 of x, we should be getting very good at this. Our ordered pairs are 1, 0, 2, 1, 4, 2, and 8, 3. +1 would be going left 1 unit. So this is left 1. So when we go left 1, that's going to change. It's going to subtract 1 from our x. So the 1 would become a 0, the 2 would become a 1, 4 becomes a 3, and 8 becomes a 7. And then subtracting 2, that would be down 2, so that's going to subtract 2 from our y value. So -2. And then 1 minus 2 is -1. 2 minus 2 is 0. 3 minus 2 is 1. The left 1, let me show you this. X plus 1 equals 0. X equals -1. That's our vertical asymptote. So our vertical asymptote is at x equals -1. Then we have our domain. Let me show you the domain. The domain is x plus 1 is greater than 0. X is greater than -1. So that would be -1 to infinity. So -1 to infinity without including -1. I'm going to plot my points, and they should all fall into place 0, -2, 1, -1, 3, 0, and 7, 1. We have a domain from -1 to infinity. We have a range from -infinity to positive infinity. We have a y-intercept of 0, -2. We have an x-intercept of 3, 0. And we have a vertical asymptote at x equals -1. Now, if you tried that and you got it, good for you. Go ahead and try the next one. If this is the first try, do yourself a favor and definitely try it. Go back and see what I did here. I tried to color coordinate and show you that when you go left 1, you're going to take away 1 from the x value. When you go down 2, you're going to take 2 away from the y value. So that's how you're going to get those new ordered pairs. Okay, if you haven't pressed pause, please press pause and do the problem. If you have pressed pause, welcome back. Here we go. We've got log base 2 of x. We've got some ordered pairs, 1, 0. We've got 2, 1, right? We've got 4, 2. And we've got 8, 3. This says we're going to go right 2 units. So going right 2 units means we're going to add 2 to the x. So 1 plus 2, 1 plus 2 is 3. 2 plus 2 is 4. 4 plus 2 is 6. And 8 plus 2 is 10. Then we've got up 1 unit. Up 1 means we're going to be adding 1 to the y value. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 2 is 4. And 3 plus 2 is 5. Did we do that right? 1 plus 2. No, we didn't. 0 plus, I started adding 2. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. We need to add 1. Add 1. 2 plus 1 is 3. And 3 plus 1 is 4. I almost said 3 plus 3. I think I was pulling in that next value. Then we have x minus 2 is equal to 0. This is our vertical asymptote. X equals 2. So going right 2 is going to translate that vertical asymptote to the right 2 units. I'm going to plot my points. 3, 1. 4, 2. 6, 3. And 10, 4. We have a domain that is, let's see our domain. X minus 2 is greater than 0. X is greater than 2. So 2 to infinity. That matches our graph. Our range goes from negative infinity to positive infinity. We don't have a y-intercept. Our x-intercept, we're going to have to do a little bit of work for our x-intercept. And our vertical asymptote is going to be x equals 2. So let me show you how we're going to do that x-intercept. So I'm going to come over here. The x-intercept is the value of x when y is 0. So I'm going to go to the original problem, this original problem right here. Put a 0 in for y. Now that we've solved equations, we can do this. I'm going to subtract 1. Now I'm going to write this in exponential form. So I've got 2 to the negative 1 power is equal to x minus 2. 2 to the negative 1 power, let me move this up. I'm going to actually resize this. I'm going to move this up a little bit so I've got some room. 1/2 is equal to x minus 2. I'm going to add 2 to both sides. 2 1/2 is 2.5. equals x. So our x-intercept is 2.5 comma 0. I'm going to check that. 1, 2.5. That looks very close to what I have on my graph. 2.5 comma 0. And that is our last answer. So this concludes our exponential and logarithmic function unit. This is our last lesson in that unit. Graphing is not too difficult once you know those parent functions. So getting to know those parent functions are super important. I hope you enjoyed this video. I hope that you at least learned something from this video, and have a great day.